11 through 16. Alright, it says, at the ruler and yardstick factory, a machine suspected to be defective. The yardstick it produces are supposed to be 3 feet long. You measure a random sample of 40 yardsticks and find that the average length is 3.02 feet and with a standard deviation of 0.03 feet. Is this evidence that the machine is producing yardsticks that are too long? Okay? And there's nothing worse than yardsticks too long. Okay? Okay, so number 11 says, is this a one-sided or a two-sided hypothesis test? It's going to be one-sided, okay? Because in the question, it's asking, do we have evidence that it's too long? So this is going to indicate that we have a one-sided hypothesis test, okay? All right. So before we go on, we got to decide, are we dealing with means or proportions? Means, okay? We're looking at the lengths of the yardsticks, and we see average length is 3.02, so we're dealing with means, okay? So what would our hypotheses be? Okay, well, do we have one sample or two samples? I only have one sample. I only have one sample, okay? So, because if you try to count, if you say I've got 2 samples, try to identify the other sample, and you can't, okay? So in this case, and again, you can look at your study guide, and it shows that for one sample mean, the null hypothesis is going to be mu is equal to some value, and then the alternative is that mu either does not equal or is greater than or something. So in this case, our null hypothesis is that mu is equal to 3. It's got to be equal to exactly 3 feet long, and then the alternative are the yardsticks longer than 3 feet long, okay? And we don't want that. All right, so number 13, what's the value of our test statistic? Okay. So the test statistic for one sample proportion, okay, it's almost always what we observe minus what the null is divided by our standard error. So in this case, the x bar that we observed was 3.02 feet. And the null hypothesis says that the yardsticks should be 3 feet long. Okay, so my x bar minus the mean is 3.02 minus 3, and then the standard error, we got one sample mean. My standard error is equal to s over the square root of n. So in this case, my s is what does the problem say? 0.03, okay. And how many yardsticks did I look at?
40.
I looked at 40, so I'm going to do 0.03 divided by the square root of 40, and I'm going to get a big thing here, okay? So if you want to do this, so you're going to have 0.02 divided by 0.00474, okay? And so you do 0.02 divided by that. I get 4.22. That's fine. So my test statistic is 4.22. That's number 13. Okay, and then on your calculator, if you want to know how to do this, I would say find the standard error first. So do 0.03 divided by, and depending on your calculator, you might have to change this, okay? But do 0.03 divided by the square root of 40 equals, okay? And then do parentheses 3.02 minus 3, close parentheses, divide button, answer button. Equal, okay? Answer is going to be whatever this number is, which is your standard error. Okay. Does that make sense? Okay, and when you do that, you should get 4.22. All right, so now we're going to our t-table. We look it up in the t-table. All right, you're going to try to look up 39 degrees of freedom, which you don't have in the t-table. So you round down to 35 degrees of freedom. And you're looking for where 4.22 fits, okay? The largest number is 2.725. And 4.22 goes beyond that. So our p-value, whatever it is going to be less than 0.005. Okay, we don't know exactly what it is, but we do know for certain that it's less than 0.005. And it says if alpha is 0.05, what is your conclusion? Number 15. Here our p-value and our alpha is 0.05. 0.005 is much less than 0.05, okay? So our p-value is less than alpha. Whenever you have the p-value less than alpha, that means you reject the null hypothesis. Always. P-value less than alpha, reject the null hypothesis. So what's your conclusion? Reject the null hypothesis. And what does that mean? It means the yardstick machine is making yardsticks that are too long. Okay? Yardsticks indeed are too long. Okay. And number 16, if this conclusion was wrong, what kind of mistake did you make? Or we have a question before we do that.
Will the alpha value always be different to us?
Most of the time, if I don't give you the alpha, assume it's 5%. Assume it's 0.05. Yeah.
Where did you get the 35 degrees of freedom?
So we would normally have n minus 1. We would do 40 minus 1, or 39 degrees of freedom. Okay? But anytime you can't find the number of degrees of freedom in the table, you always round down. So in the table, we have 35 versus 40 degrees of freedom. Okay? To be safe, you always round down. So you don't go up to 40 degrees of freedom, even though it's closer. You go down to 35 degrees of freedom. So it's just the closest one in the table. If your table had 39 degrees of freedom, use that. But our table doesn't. All right, and then last part, number 16. So we rejected the null hypothesis. If this was a mistake, what kind of error is that? Type 1 or type 2? It's a type 1 error, okay? Rejecting H0 by mistake is a type 1 error. Okay, false alarm. We think there's a difference. We think the machine is producing yardsticks that are too long, but in reality, it's just fine. We just happen to be unlucky in the sample of yardsticks we have. And you have 5 numbers there. The very first one is 1.306, and then the next number is 1.690, and then at the very end you have 2.725. Okay, so make sure, well, it's important that we know how to use this t-table here. Okay. So do you see that row? 35 degrees of freedom? Okay. So where does 4.22 fit in that lineup of numbers? You got 5 numbers, where does it fit? It's bigger than the last number, or no? Are you there? So I'm at the row 35 degrees of freedom, and it starts at 1.306 or something. Or I don't know, maybe your table's a little bit different.
The one in the book is different than the one in
Okay,
the
so I don't know, what does your book have?
30.
30, okay, so go to 30 degrees of freedom, and the first number is 1.310, and then the last number is 2.750, right?
Yeah.
Okay, so where does 4.22 fit in that lineup?
After 2.7.
Yeah, so it's after that, so how much is in the tail corresponding to 2.75? 0.005, okay?
Oh.
Okay, so because it's beyond that, your tail is going to have less than that.
Okay.
Okay? Yeah, we have another question.
Wait, so what exactly is the p-value that
Less than.
The p-value is less than 0.005.
Oh.
Okay, we don't have an exact value because our table is not that precise. So it's really small. That's all I can say. I don't know exactly what it is, but I do know that it's really small. Okay? And it's enough for me to say I'm going to reject the null hypothesis. Okay? So yeah, I think I have this posted on one of the homework pages, this t-table and z-table. This is the one that's going to show up on the final exam. Okay? So I mean, it's slightly different from the book, but it's the same concept. All right, is that good for this section?